Okay, so welcome back. And now in this next example we're going to do, we're going to use it to show how we can combine series by using a series that we're familiar with and then using that information to construct to combine series in order to construct a new series of a related function. Okay? For example, this is specific to this series here. So we know that this function, f of x, is also represented by the power series x to the n. Okay? So what we're going to do is we're going to use this representation to help us construct power series that would represent this function, which is also related to this one. Okay? So how would we do this? Okay, so we've got this function, and they're asking us to use the power series representation of f of x equal to 1 over 1 minus x to construct a power series for each of the following functions. So we've got that function there, 3x divided by the quantity 1 plus x squared. Okay, and they also want us to find the interval of convergence of the power series. Okay, so the first thing we're going to do is we're going to rewrite this function to make it look like this, right? And we've done this before. So let's rewrite this. Okay, so the first thing we're going to do is we're going to factor out the 3x. Right, we can factor out that 3x, put that up in front. Okay, and then what else do we need to do? Well, we need a negative x there. Whoops. So we need a negative x there, so we're going to have to factor out a negative. So this is going to be how do I want to do that? Yeah, so I'm going to factor out negative, so it's going to be 1 over 1 minus x squared. Now notice that the minus is outside the square, so don't make that common mistake, okay? So this is, now it's a minus of a minus, right? So all I did was change this to a subtraction with a negative, okay? Very straightforward. Okay, so now we have it in this, we have it constructed like this. Okay, so now, what does this help us? Well, now we can use what we learned in previous videos, right, in representing this. Well, how does this work? Well, this means that this power series is going to be what? Well, we take the fact that this is equal to this, and now we look at this, and we see that this is going to be negative x squared to the nth power, right? And we're going to have a 3x there as well. So when we combine that, we can write this as the summation of n equals 0 to infinity. So this is 3x. That's our a sub n, if you will. Right? Because it's always a sub n times x to the nth power, right? But in this case, a sub n is just 1. And so then this is our argument that goes here. So this is going to be negative x squared to the nth power. And that is the new series representation. Okay, so now we're not done with this, but let's simplify this even further. So this is going to be n equals 0 to infinity. 3x. Okay. This is going to be to the 2n, right? So if I rewrite this, this is actually going to be negative x to the 2n, right? Because if I use, again, property of exponents. And so now if I split this up, I've got a negative 1 there, right? So let's do, we got a negative 1. But that's going to be to the n, you know what? Hold on, don't want to, let's go back. Let's do this one more step. So this is, this was negative x squared to the nth power. Okay, but I've got a negative 1 here. So I've got to distribute the n to the negative 1 and to the square. Okay, so I was about to make a mistake there. So that should be negative 1 to the nth power. And then we've got x to the 2n okay? And then if I combine this x with here, then this x gets absorbed by this, and we get plus 1 here. So now this becomes our series representation. Now, if we go back and we look at the interval of convergence for this one, so the interval of convergence for this is negative 1 to 1. Radius of convergence is 1. Okay? So the interval of convergence for the new series is going to be the set of the real numbers x such that what? Well, such that the absolute value of x is less than 1. Or x squared, I should say. And therefore, the interval of convergence is going to be the same, negative 1 to 1. Okay, so again, straight from there. Okay, we'll come back, we'll do the next one.